We're going to talk about multiplication in algebra, but before we do that, I just need to talk about multiplication in general. If I have a problem that has more than one times sign in it, then I would actually just work my way along. I'd go 2 by 3 is 6, by 5 is 30. But funnily enough, I can also go 2 by 5 is 10, by 3 is 30. It doesn't really matter what order I multiply in as long as I multiply the three things together in the end. I could even go 5 3s are 15 by 2 is also 30. But when we're doing it with algebra, of course, we have letters representing some of the numbers that we don't know yet. Now, ignore the fact that I said 3 and 5 here. A and B could be anything. But because I don't know what they are, I can't actually just multiply them together and find an overall solution. But what I can do is simplify this because I don't want to write something this long every time. And the way we simplify in algebra, one of the first things we need to know to do is that we pretty much don't need times signs anymore. So if I want to multiply 2 by a by b, I will write 2ab, and that means the same thing. Basically, there's an invisible times sign sitting between everything. If I have 2 by a by 3 by b, however, now what I do have is two numbers that I can multiply together because they're actual numbers, whereas the a and b are still unknowns. So knowing what we were saying up here about order doesn't matter, over here I can actually do my 2 by 3, make that 6, and then put my AB afterwards. So when I'm simplifying in algebra, I want to multiply all my numbers together first and then do all my trailing letters. Where it gets a little bit more complex, however, is where I have more than one of the same kind of letter. Now this is where it does confuse people because we have numbers that represent the multiples of things. So if we're sitting a number at the front, then just like here it means invisible times. It's a nice big number, the same size as the letters. It means times. But if I put a number behind, then that's how I count timesing by itself. So the A timeses by A again. So that means I've got two of those. And that's a whole lot easier than writing what we would have written otherwise, which is that. Imagine if we had A times A times A 10 times, we would have a row 10 times long with those A's there, so that wouldn't be any good. So the little number up here, this is what we call the power. This is how many times this number has appeared. So if I've already got something that's got powers on it, of course they just carry. And if I already have something with powers on it, now this is where it starts getting confusing, and this is where I'm going to tell a story. So the actual answer, before we get any further along here, is going to be the 2 by the 6, because I have to multiply the big numbers together, and only the big numbers. So 2 6s are 12. And then I've got a squared, so that means AA. And then I've got a cubed over here, so that's another AAA. So in total, I have 5 of them hanging out times in together. And then I have the b squared, and it doesn't change because there's no other b's to multiply in with. So the way to remember this, what you need to do is you need to consider that multiplication is to do with rabbits, because rabbits multiply. So if I have 2 albino bunnies and I put them in a cage with 3 black bunnies, then I'm going to expect babies. Now, when I get my babies, I know that because of the multiplication idea, 2 3s are 6, I'm going to get 6 babies. But the babies are going to inherit from both their parents. So this parent has albino genetics and this parent has black genetics, so my babies are going to be albino black. If I have 12 square albinos, that means they've got more albino genetics than they had before, and I mix that with 3 albino black bunnies. Now I'm going to get a lot of babies in my cage. I'm going to get 12 3s, I'm going to get 36 babies in the cage, and I've got to inherit the genetics over here. So I've got to inherit the A2 and then another A. So I'm actually going to have a cubed level of albino in the genetics with the black hanging on behind. So this just continues on. It doesn't even matter. We could have 16A to the 4 times 2a to the 7. Oh dear, there's going to be a lot of babies. And they're going to have a lot of albino nature in them. So 16 twos are 32. And then with the a to the 4 and the a to the 7, I've got 4 and 7 of that power, giving me 11. So of course the trick in the end is to make sure that you multiply the big numbers together and add the small numbers together. But if I just tell you that without the bunny rabbits, it's going to be hard to remember later.